Okay. Hello, everyone. Am I audible to everyone?
Hello, sir. Yes, sir.
Yes, sir.
Yes, sir.
Okay. 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 So let's start with today's discussion. Today, I would like to discuss one of the very important as well as interesting topic as a part of the topic function, which whose discussion we have already started in couple of class ago. And the topic name of today is how to perform recursion in function. Okay, or you can say function recursion. This is the main topic of today's discussion, and you can say that this is one of the important, very important and interesting topic in C programming. Lots of questions they will get in your examination as well as in your campus interview. They will face lots of questions from this recursion topic. Okay. So it is nothing but a topic of a function topic that which we have already covered, right? So let me first tells you the basic definition of a function recursion, and then I will show you the basic program of how we can perform a function recursion, right? So what is recursion or a function recursion? So a recursion or a function recursion is a process of repeating items in a self-similar way. What I have told, a function recursion is a process of repeating items in a self-similar way. In more specifically, if we define the function recursion, then we can define it that a function recursion is a process by which one function calls itself again and again. This is the most simplest way of defining a function recursion. A function recursion is a process by which a function calls itself again and again, right? It may be a system-defined function or it may be a user-defined function. Obviously, we are applying this function recursion concept on user-defined function because we don't have a control on a predefined system-defined function, right? Or built-in function. So that's why it is preferable that we will apply the concept of function recursion on a user-defined function, right? So a function which call itself again and again, the process is called recursion. Okay. So in a programming language, if a program allows you to call a function inside the same function, then it is called a recursive call of that function. What I've said, in a programming language, if a program allows you to call a function inside the same function, okay, then it is called a recursive call of the function. Means you are calling yourself instead of calling your friend. Suppose you are throwing a birthday party. The similar example which I have already used in last couple of classes. You are throwing a birthday party. So as a sub function, you are choosing three of your friends, and individual friends is working like a sub function. Each and individual friend has his own task or own job of responsibility to organize the birthday party, and you are the main function. That is the case of the normal functions and sub function relationships. In case of recursion, instead of calling individual friends or instead of giving duties to individual sub functions or individual friends, you are the organizer of the birthday party. So you are mainly responsible to do all the activities. That means to organize the birthday cake, you are responsible. Then to organize the decoration of the birthday hall or birthday party, then also you are responsible for it. Then you are going to organize the catering or fooding flexibility of your birthday party. Then you are also responsibility to apply the to adopt the fooding facility for their birthday party. So in for all the tasks or for all the job responsibility, you are not going to rely on any one of the sub functions or any one of your friends. Instead of that, you are rely on yourself, and this is called function recursion. That means for different type of tasks, you are calling yourself, or for a similar kind of task, you are calling yourself again. Actually, function recursion is mainly applicable for the similar kind of task. You are calling yourself again and again. Then it is called function recursion. Okay. So instead of calling instead of doing the multiple function calls, okay, you are just use the recursion to call your function yourself again and again. Okay. So suppose one job in your party, one job needs to be repeated multiple times. suppose uh, suppose you want to play some music in your birthday party as a DJ, right? You are organizing a DJ, and in a DJ music you are playing. Suppose you have chosen 5 musics, okay, 5 songs to play in your DJ party, right? And those 5 songs, the playing of those 5 songs has been done by yourself only. No other friends taking the responsibility to playing those 5 songs. Only you are the organizer of the birthday party, so you are taking the sole responsibility to run those 5 songs. So after 1, 2, 3, 4, 5, all the 5 songs has been completed. Okay, suppose it has been fully played. Then you have to repeat the 5 songs again. So you have to go towards the tape recorder and then make a repeat, okay, or make a fast forward or back forward and then repeat the 5 songs again. So each and every time when the 5 songs has been played fully, then you will have to repeat the 5 songs again for the birthday party. Okay, so you are doing the same similar job multiple times in your birthday party. Suppose your birthday party timing is from 6 p.m. to 10 p.m. So 6 p.m. to 10 p.m. Suppose you have to repeat the 5 songs, suppose 20 times. Okay, and you are the only responsible. You are the only responsible to repeat those 5 songs in your birthday party for the DJ purpose. Okay, so so the work that you are doing again and again. Okay, the work that you are doing again and again. That means you are calling yourself again and again to do the same work, and this situation is called function recursion. I hope it is understood by you that what is the real life situation where we can think of function recursion. Okay, so function, so the call where when a function make itself again and again, that call is called recursive call. Okay, that call is referred as recursive call of the function. Okay, so what is the main motivation to apply or to use recursion? Recursion makes a program elegant and more readable. What I have said, recursion makes the program elegant and more readable. Okay, after using recursion, its readability of the program and elegancy of the program will be increased. So let's share my screen and show you the basic recursion program. I think the screen is visible to everyone. This is the most simplest recursion program in C programming language. Most simplest recursion program. Okay, so can anyone tell me which function here it's called itself from this program? Have you seen it?
Main function.
Yes. So from this program, it is very clearly shown that the main function is there. Only one main function is there. I am not using any sub function because I have said that this is one of the most simplest recursion function or recursion call. So that's why I don't make it complex. So this is the main method which call itself again and again. So function definition is represented here and function call is also represented here. So the control first print hello world, then comes into the main function call. When the program control comes or reaches into the main function call, it again repeat to the main function definition. That means the first line. So again it will print hello world, then again reach to main function call, and again it will reach to the or it will navigate to the first line. Then again it will print hello world. Again it will do the same similar function call. So can anyone tell me what will be the output of this program? Logically, what do you think? What will be the output of this program?
Infinite times, like it never returns zero.
Yes. So the output of this program, the program will execute this hello world statement infinite number of times. Okay. You can omit this statement. You don't need to prepare the print this statement. But if you don't print this statement, then at the output you won't understand that how many times this function will call itself. Okay. So if we run this function, this is the function call. This is the output of this function, and this is the general way. If a function call itself again and again, then this should happen. Obviously you understand that thing, this must happen, and this is called an infinite looping of the function. So function recursion will leads you to the infinite loop, will leads you to the towards the infinite looping or infinite number of execution. Okay, so I'm organizing a birthday party, so I'm playing the 20 times those songs. Okay, so if someone will not stop me, say, please, Sanjay, don't need to play the songs again. All the guests has been already left leave your birthday party. They already returned back to their home, so you don't need to repeat the DJ songs again and again. So someone is actually explicitly or externally stop you to do the same job. So you will stop to replay the five birthday songs again and again. Okay, so there should be an external stopper, okay, which will stop the execution of this infinite loop. Okay, and this is very very important in case of recursion, that programmer need to be very careful while you are using recursion because of this infinite loop kind of situation. That's why you require a special type of stopping rule or stopping criteria. What I have said, you will require a special type of stopping rule or stopping criteria which will help the function recursion to stop after a certain number of recursive function call, or to stop after a certain number of repetitions. Otherwise, if you don't use the stopping criteria or stopping rule in your recursive function program, then your program will never ever going to be ended. It will repeated infinite number of times. Okay, I think up to this, is it clear to everyone, right? So let me write some little bit more complex recursive function which is written in front of you. Here I have used one sub function which will do the similar role in terms of recursion. So I think you can understand, from the main function, I have called one user-defined function, that is recursion, whose name is recursion. It's a user-defined name. We can use any name instead of recursion. Okay. So this is a function call. Function prototype declaration is here. I think all of you are clear. I have already told multiple times, frequently time, what is the relation between function declaration, function call, and function definition. I think the conception is clear to you until now. Okay. So these are function definition. Okay, so these functions, sub functions are no return type and no argument path. The simple sub function I am using for sake of simplicity. And within this sub function definition, I have printed the statement hello recursion. And after hello recursion, I did this recursive call. So this is the function recursive call. So here it is a function recursive call, and here it is also a function recursive call. But this function recursive call has been done inside the sub function, and this function recursive call has been written inside the main function. That is the only difference. Okay, but both are the example of function recursion or function recursive call. So we will do the same job again and again, but obviously if we execute this program, the output will be similar. The output will be similar. So infinite number of execution of the hello recursion statement, right? So up to this function recursion is clear to everyone. Has everyone understood it? Has everyone understood it? Is it clear to everyone?
Yes, sir.
Okay,
Yes, sir.
very good. Now, I would like to tell you some important mathematical functions or some important mathematical operations we can do with the help of function recursion. So first advantage or benefit of using function recursion, which I have already told you, that function recursion makes your program elegant and more readable, right? Makes your program elegant and more readable. And where you will need to perform the similar job, you don't need to call your function again and again. You will just do the recursive call. That will be enough to do. If you perform the similar type of operations again and again in a particular program, you just apply function recursion for it. Okay, instead of writing more number of codes. So that's why I have told that function recursion make your program more elegant and more readable. Okay, if you reduce the number of lines, number of codes, then obviously the readability of the program will increase. Okay, but here till now I didn't show you the use of the stopping rule or stopping criteria, which is very very important. Otherwise, obviously, infinite output, no one required infinite output in your C programming, because I have already told all the algorithms programs should be finite in nature. It has some finite output as well as finite input, right? So some of the important problems or some of the important mathematical kind of things we can do with the help of function recursion very easily compared to a normal way. As for example, to find a factorial of a number, to find a factorial of a number. We can do this job with the help of function recursion in more efficient way compared to the general function calling. So I have already told you, I have already shown you two types of program of calculating factorial. One by using only one function, that is main method, and a second kind of program I have shown by using sub function fact, how to do how to calculate the factorial or how to find the factorial of a number. Here I am going to show you how to use the function recursion to do a factorial of a number. And here please remember, I want a finite output. Obviously factorial of a number should have a finite output, otherwise we won't get any output, right? So that's why we have to use the stopping criteria or stopping rule here. That is very, very important in case of factorial function. Apart from factorial recursion, we can apply recursion where we need to find a power of a number. Power, okay, maybe 2 to the power 4, 4 to the power 2, like this. The power of a number, we can apply function recursion there. Then if we perform the GCD, greatest common divisor, if we find the GCD between two numbers, we can apply the function recursion there. If we perform the Fibonacci series, we can use a function recursion to perform Fibonacci recursion series. Okay, any kind of Fibonacci which has some sort of similar kind of rotation in the series, we can use a function recursion. Okay, so these are the very common areas where the function recursion can be applied. In next semester, in data structure subject, you will learn this function recursion in more deeper way, with the applications of towers of Hanoi, with the application of uh, some more interesting algorithms there. Okay, like finding the n natural number, sum of the n natural numbers, we can also perform with the help of function recursion. Finding the sum of n natural numbers. So where we actually apply the similar kind of concept again and again. In that places, in that situation, we are able to apply the function recursion. That makes it clear to everyone. Okay, that makes it ensured. Okay. So let's check the factorial program first. So this is the factorial program. So this is a factorial function, user-defined function product declaration, which has one return type int and one argument is integer also. Then these are the variables which I make it as a global variable declarations, your choice. Okay. Then the main function. Within the main function, I entered a number whose factorial I need to calculate. Then call the factorial function by passing that number whose factorial I need to calculate. Obviously, it's an integer number, so that's why I have taken int as an argument there, right? So from here, the program control reaches where? Reaches into the function definition. Where is which one is the function definition here? This one is the function definition here. Okay. So obviously the function prototype, function call, and function definition should have a similar kind of return type and argument passing. Okay. So within the function definition, only this part we are doing the recursive call. Only this is a recursive call. Only this line is a recursive call, and this two line is used for the stopping rule or stopping criteria. That means recursive call should be stopped after a certain criteria will fulfill. Okay, otherwise it will give infinite output that you have already seen. Okay, so what I did in a recursive call. So to do the factorial, I did this simple recursive call, n into the factorial function itself, n minus 1. So if you see this portion of the program, you see that this factorial function is again calling itself. Okay, within factorial, again factorial is calling, which I have already shown in the previous program. Within recursion, a recursion function is calling. Okay, so here within factorial, a factorial function is calling with a less number of input, that is n minus 1. It requires how? Suppose the value of n has been given n equal to 5, which I have already shown here. Okay, has been given input. So in the first case, so n is when n equals to 1, the stopping criteria says if the value of n becomes 1, then it will return 1. Otherwise, it will returns always the else part, right? So in the first case, when n equals to 5, obviously this criteria does not satisfy. So the program controls reaches into the else part. So in the else part, we will calculate 5 into factorial of 5 minus 1. That means what? Factorial of 4. I think it is clear to you. Now within this function, again the entire function will be calculated. Okay. This function means this function call itself with a 1 less value of 5, that is 4. So factorial 4 means again this part will be calculated. So 5 into again 4 into factorial of 3. I think you can understand. So in the next case, when the function call itself, next case the value of n becomes 4 and the factorial value becomes 4 minus 1, that means 3, and which will be multiplied with the previous value, that is 5, because it should be replaced. The new function formula will be replaced the old one because the function call itself again and again. Again this factorial 3 will be repeated or call itself, because till now the n is not equals to 1, so it will repeat. So in that case 5 into 4 into 3 into factorial of 2, again n not equals to 1 till now, so it will again call itself. So 5 into 4 into 3 into now factorial of 1. When it becomes factorial of 1, this is actually factorial of 1. Now when it becomes factorial of 1, okay, that means the value of n is now 1. When the value of n is 1, it will simply return 1. So this function is fully replaced by a new value, that is 1. Okay, because it is written here. Okay, so it is replaced by 1. So that means it actually give the multiplication value of 5 into 4 into 3 into 2 into 1 is equal to 120. Okay, so the after the stopping criteria, the program control again returns to this received part where the value has been received by a third variable, which you can do, it's optional. Okay, or you can directly print the value here, it's your choice, and then print the third variable separately in the next line. So I'm executing this statement. So enter your number, suppose 5, and the factorial of this number is 120. Clear? Everyone clear? Is anyone has any problem? Any doubt? You can ask me. Is it clear to everyone?
Yes, sir.
Anyone any doubt, any problem regarding this factorial? No problem. Is it clear to everyone? Recursive call and stopping criteria, is it clear to everyone? So why stopping criteria is required? Because it has to be stopped at a particular, after a particular repetition. Okay, that's why stopping criteria will be required. Otherwise it will multiply with some zero value at the end, and the entire value will be 0. Okay, you can also write this stopping criteria as n equal to 0. Okay, which will return 1, because when n becomes 0, n minus 1, so 1 into 1 is again multiplied. So one time the loop will be extra executed. You can also write this stopping criteria as n equal to 0, return 1. The program will run successfully, I think so. Okay, there is no changes, because when the value it becomes 1, so in this case 1 into 1 extra 1 will be multiplied. So I don't need to repeat the similar multiplication of 1 once more. Why should I waste my time? Why should I increase the time capacity of the program? Okay, that's why I have stopped by taking the value of n. When the value of n is equal to 1, I will call the stopping criteria, or I will stop the program here. Now going for the next program, Fibonacci series. Okay, in our lab I will give you some more programs. So all of you must practice these 2 programs by understanding it, how you can perform it. Apart from this, you can apply the function recursion for the n natural numbers, sum of n natural numbers. Then you can apply function recursion for performing GCD, greatest common divisor between 2 numbers. You can apply function recursion while you are performing the calculating the power of a number. Okay, so this is the program that you can practice at your home, or in lab I will give those programs for your assignment, as your assignment. Okay, so these are Fibonacci series. I think all of you are remember the Fibonacci series. This is the Fibonacci series. So Fibonacci series logic was the addition of the previous 2 number will give you the third number. Okay, that means the next number. So the next number is actually nothing but the addition of the first 2 numbers. Okay, previous 2 numbers. So this is the Fibonacci series. Okay, the logic of Fibonacci series, everyone knows it. So this is a fifth function I have called for Fibonacci series logic. Okay, and these things is very much familiar with you. So this is the range up to which your Fibonacci series will be printed, and the for loop will run from 0, starting from 0 to up to that range, and each and every case it will call that fib I function. Okay, so I is the integer that pass through it. Okay, I is the integer value that pass through it. So this is the Fibonacci series, and it has been written in a recursive form. Okay, it has been written in a recursive form or recursive way. So what is the recursive way? Look at this very Fibonacci series very carefully. So fib of n minus 1 plus fib of n minus 2. So suppose the n you have given 8. Suppose the n you have given 8. So you want to check the range of 1, 2, 3, 4, 5, 6, 7, 8. So you have to check the range up to 13. So that's why you have given the value of the range of this series that the output you want is up to 8, right? So n becomes 8. So it will first enter with the value when fib of I. Okay, fib of I. Okay, so in the first case, the value of I is actually 0. So value of I is 0. Okay, so it will enter with a value of 0. So when it's 0, it first prints 0, because when n equals to 0, that means I start with 0 because for loop is 0. So it will first print the value 0, right? Okay. Next, it will enter into if loop. So it will never enter into the other loop. Okay, so it will return the for the next call, that is when I is incremented by 1. So now the I value becomes 1. So when the I value is 1, which part will execute? The second part, the second else if part will execute. Okay, so 1 will be printed. I think it is clear to everyone. So again, it will incremented by I plus plus. So I becomes 3 right now, and this Fibonacci function is called itself again. Okay, itself again. Now, when I becomes 3, these two criteria will not execute. Obviously, you want to understand this. These two criteria will not execute. So it will execute this criteria. Okay, else part. And inside the else part, you will see that this fifth function call itself again and again with two different parameters. The first parameter is n minus 1, and the second parameter is n minus 2, and then it will perform summation or addition between these two parameters. Okay, so fib n minus 1. First fit the value of n. When n becomes 3, it should be n minus 1 means 3 minus 1 means fib of 2 plus fib of 1, fib of 2 plus fib of 1. Okay, so this fib of 2, this fib of 2 will again call itself. Okay, for again call itself means fib of 2 means here you cannot take any decision here because this is 0 and 1. So fib of 2 plus fib of 1. So fib of 1 means this function will call for 1. So fib of 1 means this one. So it will print 1. Okay. Okay. Now fib of 2 plus fib of 1. So now fib of 2 is called itself again. So that will becomes 1 in the next case because fib of 2 minus 2. So if fib of 2 minus 1, that means 1. So previous one is fib of 1 means 1, and next one will be fib of 1 again. So 1 plus 1, 2. So in this way, it will increment. So when the value of I becomes 4, it should be fib of 3 plus fib of 2. So fib of 2 is again divided into fib of 2 plus fib of 1. And so fib of 1 means 1. And that will be added with the previous 2, 2 plus 1, 3. Okay, so in this case, it will give you 3. And in this way, the series will increment it. Okay, understand? Everyone understood this? Has everyone understand this? Is
Yes,
it
sir.
clear to everyone? Right. So these two programs are very, very important to apply for recursion. So in examination, they will ask you the question that what is function recursion, what is recursive call, and write one program to explain function recursion extensively or briefly along with the stopping criteria, stopping rule. Please remember, you can give this kind of example as a function recursion. You can give it, it's allowed, but if you have enough time or if you have a proper example to give, then you can either give factorial, which most of the people prefer to give because it's easier to give, or you can give Fibonacci recursion or any other program where the stopping criteria, stopping rule is embedded. Okay, so try to avoid to give such an example where the stopping criteria is not there. Okay, you have to mention the stopping criteria along with your program, right? So this is all about function recursion. Okay. Now the second thing that I need to discuss with you, this thing I have left during the discussion of the types of variable, how many different types or different categories of variable into the variable chapter. I think you remembered it, that there are six kinds of variables I have discussed. One is local variable, global variable. Second one is global variable. Third one is automatic variable. Fourth one is static variable. Fifth one is external variable, and sixth one is register variable. And these all variables are called storage classes in C programming. What are the various kind of storage classes in C programming? These are the various kind of storage classes in C programming. Especially the last four are the main kind of storage classes in C programming: automatic, static, external, and register. Okay. So among these six kind of variable or six types of variable, local and global variable, I have already discussed. I don't want to repeat it again. Okay. I think all of you have remembered the use of local variable and global variable, right? Now I want to discuss with this rest of the four variables, which is very important in examination. These questions has repeatedly come. Okay, frequently come. Okay, even in interview, exam, or even gate examination, they will ask these questions. Okay, automatic, static, external, and register variable. So try to understand it very carefully. Automatic variable. Okay, so can anyone has any idea about automatic variable? Any idea? What is automatic variable? Have you used that variable yet in your program? Have you used it? What do you think? Have you used the automatic variable yet? What do you think? No idea. Okay, your silence, I will keep it as, I will assume it as no idea of automatic variable. Yes.
for loop টা কি অটোমেটিক ভেরিয়েবলের মধ্যে পড়ে?
No. Actually, all kinds of input variable that you have declared within a function, it may be a main function, it may be a sub functions. All kinds of normal variable or local variables are automatic variable by default. So you have already used automatic variable in various programs, right? So let's check this program. Just overlook the command lines. Okay, let's check this program. Int function is a sub function where int fun is a sub function where I have called this sub function from the main method 2 times. Okay, this is a function called 1, this is a function called 2. The same first sub function I have called 2 times. Okay, here you can use recursion, but I'm just calling, make it simple. This is not related with recursion. This is simply different from recursion. Okay, now from this sub function I have defined the sub function here as int fun. Function definition has been here written here. Now within this I have used this auto keyword. This auto keyword among those 32 keywords in C programming. So this auto keyword is used to represent this variable as an automatic variable. Okay, so counter one count variable I have declared whose initialized value is 0, and then make counter plus plus and then return the count value. I think this is a very easy program that you can understand. Okay, so what is the output of this program? If we run it, 1 1. So output of this program for the automatic variable is 1 1. For both the function it will give you 1 1. Okay. Achha. If we remove the auto keyword from the in front of the count variable, then what will the output? Again 1 1. So I think you can understand there is no use of auto variable explicitly, because by default the C compiler assume a local variable as a automatic variable. Clear? Everyone clear? So there is no use. So you may use auto keyword explicitly in front of a variable, or you may not. Okay, if you don't, then C compiler will automatically assume it as an auto variable. Clear? I think it is clear to everyone. Now the use of static variable, which is very, very important. Look at the program very carefully. This is a non-static variable because I did not use any static keyword in front of that variable. That's why it's a non-static variable, right? So what is the output of the non-static variable? 1 1. Very clear. 2 times the function will call. That's why 1 1. Now, if I will add a static keyword in front of the count variable, while where we have declared initial as a variable, what is the output of this function of this program? 1 2. So can anyone tell me What is the use of static variable? What do you understand from the output?
It will use only one time. Like static can be allowed only one time.
Anyone else? Anyone else? I need some proper answer. Can anyone explain it? Why the output 1 or 2?